Welcome, everyone, to another episode of Natural Philosophers, the show in which I talk to some of the leading natural philosophers of the day about some fascinating topic that they've been working on. I'm your host, Dr. Siddharth Mathakrishnan. My guest today is Professor Alastair Wilson. Al is a professor of philosophy at the University of Birmingham, where he works on metaphysics and the philosophy of physics. Today, I'll be talking to him about his new book, The Nature of Contingency, Quantum Physics as Modal Realism, where he defends roughly the view that the many worlds interpretation of quantum mechanics provides us with a new metaphysics of modality. It's a wonderful book written with clarity and rigor, and it offers powerful ways of reconceptualizing and dissolving away issues that arise when we are thinking about the many worlds interpretation. Welcome, Al.
Thank you for having me on, and thank you for that generous introduction.
So let's start with a few questions about metaphysics broadly construed before we get to your book itself. My original training was in physics, and I moved to philosophy. And when I moved to philosophy and I said that I was interested in metaphysics to some of my friends in physics, and they had this reaction of what on earth is metaphysics and if I tell them something like metaphysics is interested in questions like the nature of reality, the nature of space and time, the nature of causation and things like that, they tended to have the reaction, well, isn't that just physics or computer science or things like that? So how would you think about the subject matter of metaphysics as distinct from different disciplines?
Well, yeah, nobody agrees about exactly what metaphysics is. The name doesn't, I think, help very much, because the natural thing people think of when they hear the term metaphysics, apart from kind of connections with crystals and the New Age, which is what you'll find if you go into a bookstore and look for metaphysics. In academic philosophy, metaphysics, the term makes it sound as though it's kind of physics removed to the meta level. So it's like one step more foundational than physics. And you might compare like logic and metalogic, where metalogic is, broadly speaking, kind of logic about logic. And so there is a sense that for a lot of people that metalogic is more foundational than logic. And in the same way people might expect metaphysics to be more foundational than physics, a lot of people that do metaphysics do think they're doing something kind of deep and more profound, more important than physics. They're doing something like building a foundation for any possible physics. So this is what people often call themselves Aristotelians and neo-Aristotelians like to think about metaphysics. They think of it as kind of first philosophy. And so what they're doing is, in a sense, deeper, more profound and more important than what physicists are doing. Even if the physicists can make good predictions and build impressive machines, somehow the philosophers are doing something that is more important. And I don't buy that kind of attitude at all. I think metaphysics is different from physics in terms of being more abstract and more general. And so the questions are different questions, but they're not more foundational questions, either in a metaphysical or epistemological sense. And we're certainly not in the epistemological sense, we're not more certain of metaphysics than we are of physics. And the way I look at it is actually quite the other way around. Physics is our great solid anchor in these areas of the kind of very abstract, because physics has proven itself through experiments and through technologies. It's the obvious epistemic starting point here. And so I see the job of metaphysics as being kind of to make sense of how physics can be possible. So there's certainly no sense in which metaphysics is to be done first. I would think physics is to be done first, looked at, and then understood and interpreted. And when you understand metaphysics like that, there isn't a sharp boundary between metaphysics and physics. In fact, I like to think of them as overlapping, like to a large extent. There are questions which are clearly just physics, kind of details of the like acoustics within a like highly stressed material or something. And then there are things which are clearly metaphysics, kind of question about the, numbers, for example, the nature, the reality of numbers. And then there are questions that are in the borderland that I think are correctly counted as both physical and metaphysical questions, such as what are alternative possibilities? That's the metaphysical question, which is the subject of the book. But as I argue, it can be answered using physics. So in that sense, it's a question that is within the intersection of metaphysics and physics. And so, yeah, metaphysics of physics, which is the kind of thing I like to think I do, is not trying to give some a priori foundation for physics. It's trying to fill out the physics into a full, complete, consistent story, and to do that in the best way we possibly can. And to do that, it needs to be cognizant of and also appropriately deferential to the physics, because the physics is making these amazing predictions, building these amazing technologies. Metaphysics has done nothing of the sort for us. Metaphysics, nobody has invented some technology that has made life easier using the theories of metaphysics, or at least it would be pretty contentious to say that we have. So there's a lot more to say about this, but the kind of thing I do, I call naturalistic metaphysics. This is a term that other people have used, and broadly speaking, it means metaphysics that takes natural science as the appropriate kind of starting point and as something to be deferred to in appropriate ways.
So this way of conceptualizing metaphysics, which you prefer, avoids a line of criticism that's quite often leveled against metaphysics, which is that it makes heavy use of intuition or assumes a kind of a priori access to the structure of the world. Do you think that this line of criticism is largely valid outside of naturalized metaphysics?
Well, I have mixed feelings about this, because one thing a lot of people have said for decades and still say is that metaphysics is nonsense, and the metaphysics that's done from the armchair is nonsense. And I don't believe that. I think it's very hard to substantiate claims of nonsensicality. People might say that these things are not worth pursuing, or that their answers are kind of trivial, or in some other way the pursuit of them is misguided. But I just tend to think that these are perfectly good questions for which the people are often using the wrong methods. So I do think conceivability, in particular intuitions of the possibility of something that go along the lines of imagining something, judging it to be a kind of coherent thing to imagine, and then inferring that it's possible. That particular inferential step, leading you to the claim that such and such a thing is metaphysically possible, as it's often said, is used heavily in metaphysics. And insofar as that's an a priori inference, I reject it. And the book provides, amongst other things, a naturalistic replacement for the method of judging possibility using a priori conceiving. Instead, I think we should just kind of apply science directly to assess possibility claims insofar as we can. Doesn't mean we'll always be able to do that, but so there's a certain sense in which my book debunks the kind of method which is prevalent, I think, in analytic metaphysics. Just one example, which I expect many of your listeners are familiar with, the argument from zombies for non-physicalist views of consciousness. People like David Chalmers most prominently have argued that because zombies are conceivable, therefore they're metaphysically possible, and if they're metaphysically possible, there can't be a constitutive connection between matter and consciousness. And I just reject that argument at the first step. The fact that zombies are conceivable doesn't mean that they're metaphysically possible, and it doesn't mean we need to take account of their metaphysical possibility in building our best total theory of the world. So I think this view can actually be used to shore up a lot of plausible positions against like overly zealous a priori arguments from philosophers.
And in the aspect of a priori knowledge, some people try to justify the methodology of metaphysics by saying that we already have a very successful a priori enterprise, which is mathematics. And if mathematics is allowed to sort of go along its merry way without being subjected to severe criticism for claims of knowledge, why should metaphysics also be not allowed that same latitude? Do you agree with this way of thinking about metaphysics as a kind of mathematical knowledge?
Yeah, I don't agree, though I acknowledge the power of that line of thought. We'll talk later, I think, about David Lewis and his modal realism. But Lewis was kind of intensely impressed by the power of mathematics as something, the kind of achievements of which it would be absurd to deny, in a way that philosophy can't produce any comparable achievements that it would be absurd to deny. So I share that attitude that there's something enormously impressive about mathematics as an a priori enterprise, but I still think the jury is out on how exactly to understand what it is that mathematics is doing and how it works, and what it is discovering. My own preference, though it's a tentative one, is towards a form of Pythagoreanism, which brings mathematics and concrete reality together. Whether you want to say reality is mathematical or mathematics is kind of encoded into reality is maybe a matter of preference. But I think so that's a bigger view than I have ever defended or can defend here. But I think it is one of very few candidate answers to one of the deepest questions of metaphysics, which is the making sense of the applicability of mathematics to the natural world. And it's not just the stupendous achievements of particle physics that give rise to a problem of applicability of mathematics, though it is particularly striking there. I think even like geometry of patterns in the natural world already gives rise to some deep questions about applicability of mathematics, which most philosophers I don't think really have an adequate answer to. I think it's kind of a gigantic unsolved philosophical problem that people have ignored because it's just too hard. And some heroic philosophers have wrestled with it and some still do. So I think, as I say, I think the jury is out on how to understand the achievements of mathematics, but my own preference is for a view which makes mathematical knowledge not ultimately of a kind so distinct from metaphysical and physical knowledge. The structure of the world extremely broadly construed.
So let's turn to your book. Since we already had a bit of a conversation about methodology, and one of the things that I like about your book is that it sets out pretty clearly the methodological principles that you will follow. And together, the principles that you will follow, you call it a Quinean methodology. So, and you have various principles under that methodology, you sort of complicated sounding names like interpretational metasemantics, conformational holism, physics, metaphysics, evidential asymmetry. So I know it's probably hard for you to summarize these deep ideas very quickly, but perhaps can you give us a broad feeling for what the methodology here is?
Yeah, So I say it's Quinean because it is a kind of holist epistemology, which is often associated with Quine, and it's also a naturalist epistemology, which sees no sharp divide between the questions of philosophy and the questions of science. So, broadly speaking, the holist element of that is conformational holism here, is the idea that we should evaluate theories at as global a level as we can, taking as all the considerations into account collectively, rather than evaluating different elements of theory in isolation, because everything is in principle evidentially linked to everything else. That's the kind of guiding idea. One shouldn't assign kind of credence zero to the something in one area turning out to bear in an unexpected way, even if only indirectly, even if only conditional on some obscure hypothesis, on something else very far away. So you should in principle be open to the idea that everything could in principle bear on everything else. And that means, as Quine would put it, that it's only like a total system of the world that you can compare against another total system of the world ultimately. And everything else we do inferentially is kind of a shortcut to that. That's the kind of ideal thing. If we were ideal reasoners, we would like kind of gather all the facts, and we would sit down and try to work out what the best total theory was. So that's conformational holism. Interpretational metasemantics says that if we did that, if we were the ideal reasoners, we gathered all the facts, we sat down and considered what the best theory was, there wouldn't be anything more to the theory we settled on being true than it being the one that we would in that situation settle upon. This is the kind of hardest one to explain. What it kind of rules out is the possibility of kind of radical error, even in the ideal limit, of the kind that you would get if it just so turned out that your words ended up referring to something completely different from what you thought they referred to. So you tried to express your theory, but you ended up expressing nonsense or nothing true. I'm not going to try and dwell on that. It's not my forte, as no doubt anybody listening to the last 30 seconds has gathered. The most important of these, kind of for the purpose of the book, is something I've already mentioned. The idea that if there's like a direct tension between some well-confirmed piece of physics and some like firmly believed piece of metaphysics, it should be the metaphysics that gives way. If there is genuinely a tension there, physics generally has a much better evidential standing than metaphysics. So that comes in degrees, but it's meant to push back against the kind of people that would say, well, our knowledge in physics is always tentative, but our knowledge of metaphysics can be a priori and certain and perfect. And so where they come into conflict, it should be the metaphysics that gives way. I take the other approach, as I've already explained. If there's genuine tension between physics and metaphysics, we need to find a metaphysical workaround.
Right. So broadly, your methodology is one in which you try very hard to respect exactly what the physics is saying, but at the same time, you are trying to fit together our grasp of physics with our grasp of the rest of the world in a kind of holistic way, in the sense you also want to take into account our knowledge of the everyday world, our ordinary patterns of language use, and fit them all together into one theory that sort of respects everybody. It's a kind of, I mean, compromise sounds like a weak word, and what it is more like a best fit, perhaps. Is that a better?
It's a balance.
Okay.
Absolutely. It is the theory that best balances the overall theoretical virtues. That's one way to think about it. So we're kind of looking at kind of candidates for total theories of the world, and comparing them. I mean, like the first basic condition is that they should fit the empirical evidence, or like be fittable to the empirical evidence in some natural way. But beyond that, it's criteria like simplicity and obviously like predictive accuracy. One doesn't need to have your total theory predicting every detail, because some things might just be random, especially with quantum mechanics around. You shouldn't expect every single occurrent fact there is to get a full explanation. But you want your total theory to explain as much as possible, as efficiently as possible. That's broadly the trade-off that David Lewis endorsed for total systems of law. His methodology is broadly Quinean too, though he didn't endorse the physics metaphysics evidential asymmetry in the way that I do, and that's why my metaphysics looks rather different from Lewis's.
Wonderful. So let's talk about the main subject matter of your book, which is modality. And as you mentioned, this is a topic that is often used as a key example of the kind of question that metaphysics is concerned with, that say physics is not concerned with, or mathematics is not concerned with. So, and modality deals with concepts like actuality and possibility, necessity and contingency, or sort of more simply, it's about ordinary modal language when I say, I'm doing this interview, but I could have been not doing this interview. So this ability of humans to talk about alternate possibilities, and saying that also about necessities, no matter what happened, this would have happened. So why is this topic so compelling and puzzling for philosophers?
Well, it's a good question, because initially these words, actual, possible, necessary, contingent, they don't seem hugely central, and you know, they're long words. I do think that these notions are very, very central within metaphysics. When you start trying to theorize about various specific aspects of the world around us, causation, personal identity, these kinds of central metaphysical topics, modality kind of keeps coming up as a core tool that people use when explaining concepts. So like one candidate explanation of essence, people don't always like this, but an essential property is a property that a thing has in every possibility in which it exists. And so that's characterizing a term like essence using possibility, and counterfactuals are the kind of elephant in the room here, because even though we don't use the word possible all that much, we use words like could and can and would more. But we do use counterfactuals all the time. So a counterfactual, I'm assuming most people know in this context, is a conditional of the form, if such and such had occurred, such and such other thing would have occurred. And these counterfactuals are also like very frequently the kind of things that philosophers and theorists in other disciplines find themselves reaching for when they want to explain concepts. So you know, you want to explain kind of personal identity. You talk about who would be you in some hypothetical counterfactual scenario. If you were to go into a teletransporter, who would come out? And so they get used all the time in philosophy. But more relevantly, really, for the kind of the importance of this topic is just how much we use them in everyday life. We're always talking about what we would have done differently, how lucky we are that we did this, because if we hadn't, this other thing would have happened. How unfortunate we are that our alarm failed to go off. If it hadn't, it would like surely have got got to work on time for once. There's so much hypothetical thinking all over our lives, not just kind of indicative conditional thinking of the form, well, if this is the question, then this is the answer. If this is the question, then that is the answer. That kind of simple if-then thinking doesn't have a counterfactual element. It's if this had been the case, it would have been the case, which is sometimes called subjunctive mood in grammar, that seems to mark this distinctive phenomenon. And it's that distinctive phenomenon, hello dog, which we use all the time. And it also seems to be tied to causation. Causation seems to be very closely linked to what would have happened. The cause is something that makes a difference. If the cause were absent, then the effect would have been absent too. And causal thinking is obviously endemic in our reasoning, in our theorizing. And so all this adds up to like a very big cognitive theoretical role for counterfactual thinking. And counterfactual thinking just is modal thinking. It's reasoning about other possibilities. At least that's a first pass natural way of understanding counterfactual. It's about counterfactuals are telling us about how things would have been if other things had been different. That is, they're telling us about how things are in alternative possibilities of particular kinds. At least that's the core idea behind the account of counterfactuals that I like and which I talk about in the book. So modality is everywhere, and the question is how can we make sense of that? And one of the most striking things philosophically is that it's really hard to make sense of. One of the things I argue in the introduction to the book is that collectively philosophers have done a really pretty terrible job of accounting for modality, and often of like even appreciating the substance of what needs to be accounted for.
Right. So the question here is, what is it that we're talking about when we're talking about counterfactuals and possibilities? And ordinarily, ordinary language seems pretty straightforward. If I say my coffee cup, I'm talking about this. So I have sort of a idea of what kinds of things I'm talking about in ordinary language. But when we're talking about possibilities, alternate possibilities or counterfactuals, then it seems as if there's nothing really in the world that we can point to, well, at least until your thesis comes to the table. There seems to be nothing in the world that we can point to and say that, well, that's what we're talking about when we're talking about possibility. And this is why, if I understand correctly, this is why this is a topic for metaphysics rather than just say psychology, right? Because psychologists might say, okay, how do humans actually do counterfactual thinking and use this language? But the question isn't how we do that, but the question is really, what is it that is the subject matter of that conversation, right?
And absolutely, that's a good summary. But alongside that question is the kind of functional question of what, I mean, that question has to be answered in a way which makes sense of why we use this language so extensively. So we don't need to just kind of come up with some stuff that we could be talking about when we use counterfactuals and use modal language. We need to make sense of how we would benefit from talking about those things and why we have such an extensive practice of doing that. And that, I think, this kind of question of the function of modal language has been really heavily underappreciated. And most of the theories of what modality is, the different theories of possible worlds and so on, do a pretty bad job of making sense of why we would care about modality. That's really a big challenge. They also do a bad job of making sense of how we know facts about modality. So if facts about modality are facts about these primitive abstract objects, some say, or a fact about these kind of concrete universes physically completely cut off from our own, again, very unclear how we could know about these things, or why we would care about them enough to talk about them all the time. So there's a big challenge here, not just to come up with a view which kind of gets the truth values of our modal claims right, but a view which gets them right in a way that makes sense of why we use them. And in many ways, the best theory on the table is, apart from the view that I like, I think, is a kind of essentialist view, a dispositionalist kind of view, which says that things have their causal powers essentially. And so it kind of flows from the nature of things that they can and can't behave in certain ways. And that view, I think, does better than many of the other ones on the table. And I don't give it an extended discussion in my book, which I regret. But even then, those views don't feel explanatory at all to me. It feels like we're being asked kind of, why can this thing do these things and not the others? Well, just in the essence of this, to be able to do these things and not the others. It doesn't really get us very far. Whereas what I'm trying to do is to link the answers to these questions to other theories which are well-confirmed theories in their own right. And that's where quantum mechanics comes in.
Right. Yeah, so with an essentialist theory, I would say, if someone asked me, why is it the case that had I struck a matchstick, it would light up? And I just said, well, it's the essence of a matchstick that it has that property that upon striking it tends to light up.
In other words, it's flammable.
Right. Yeah. That would be quite unsatisfactory as an explanation. I would have just sort of restated the claim. So, right.
So that gets called a kind of normative virtue objection. After the old idea that it's a non-explanation to say that opium sends you to sleep because it has a normative virtue. Where what is a normative virtue? Well, it's the power to send somebody to sleep. Feels like you've given an explanation which is so limited, it's almost circular. It maybe says one thing, which is that there is like an intrinsic property of the opium that sends you to sleep. Maybe the dispositionalists say this one thing, there are properties that are like intrinsic to you and me that give rise to the necessities and possibilities that we have. But until you say something more, that's not a satisfactory theory, I think. You haven't said what it is or how it works. And in quantum theory, what I take it is that we have a mathematically precise theory of modality. I said that I thought some theories, some claims could be both physics and metaphysics. And I take it that like the physics of quantum theory just is continuous with the metaphysics of modality. What quantum theory is telling us when it assigns probabilities to different possible outcomes of some physical process is it's telling us about what the genuine possibilities are. And it's telling us more than traditional modal metaphysics ever told us about what the possibilities are, because it's assigning a probability distribution over them. And so the kind of modal metaphysics which you get out of quantum mechanics is both kind of more physically grounded than the kind that you get out of a priori conceiving, but it's also just richer and more powerful because it has a probability measure over it. And so you can do things with it. In particular, you can account for how we know things about it and for its rational role in our lives by linking up with the role of chance in our lives and the role of experimental statistics in assessing chances. So it's really that probability distribution which kind of comes with the possible worlds of my version of quantum theory that isn't there in the possible worlds of traditional modal metaphysics. And that is what kind of breaks the deadlock and allows certain explanations to be given by my account that couldn't be given by previous theories.
Right. Okay, great. So since you've been dancing around this and you give a nice statement of some of the ideas of your thesis, perhaps maybe you could just say a little bit more about your thesis, which you call quantum modal realism, and you see it as a kind of combination of the many worlds theory of quantum mechanics, or also called Everettian quantum mechanics after Hugh Everett, who first proposed that idea, and also what gets called modal realism, which is a thesis by David Lewis. So we're going to take the two theories, especially quantum mechanics, in more detail in the following questions, but perhaps you can just sort of briefly summarize to situate the discussion, the thesis that you're defending.
Sure. So quantum modal realism is a theory about what modality amounts to, what it consists in, what it is as a phenomenon. And really the core phenomenon I take to need explaining is contingency. The phenomenon that some things are some way, but could have been some other way. So I'm not in the first part interested in explaining necessity, why some things couldn't have been any other way, which is normally what philosophers try to explain. I'm focusing on the mystery of contingency, the fact that for some things in the world, they could have gone differently. Like, what does that amount to? And the core claim is that contingency is variation across different worlds in the Everettian multiverse. So the Everettian multiverse, as I conceive it, is a collection of worlds. It's a collection of parallel worlds rather than a splitting tree of worlds. And that is an important feature of the view that distinguishes it from many approaches to Everettian quantum mechanics, which we perhaps will talk about. But in my kind of forest of parallel worlds, different things happen in different worlds. And we're in one of them. And contingency is a phenomenon that what happens in our world is what we call actual, but there are other worlds which are counterparts of our world, and contingency is variation across those. And the reason that it's useful for us to think about these other worlds is that we can't tell which world we're in just by looking at the evidence available to us. In particular, we can't tell what the future of our world is going to be like. We want to know what the future of our world is going to be like. But what we can know from looking at the past is what the probability distribution over worlds that are relevantly like ours, in that they have a common past, is like. So if we look at enough of the past and do enough science to work out how to get probabilities for future events out of knowledge of the present, then we can look at the present and make predictions about the future. And all of that comes from us finding out information about where we are in this gigantic collection of worlds. So the core claim, to come back to, is that contingency is a matter of variation across possible worlds, and to be the actual world is just to be the one we're in. So we're in our world, you, me, everybody listening to this is all in the same world. And there are other people just like us in other worlds. And their world is actual to them, just like our world is actual to us. And there's no deep difference of kind between our world and their world. The difference between our world being actual for us and their world being actual for them is just like 2020 being present for us, but 1800 being present for Napoleon, or Pittsburgh being here for you and Oxford being here for me. Actuality becomes indexical. It's a matter of where you are in reality. That's your actual world. And so that's a kind of transformation of perspective of a radical kind that has been compared to a kind of Copernican shift. When you think that the actual world is all there is, and the way things actually go is exhausts reality, and then you find out that you're actually just one of very many, and the others are prioritizing themselves. And it isn't, I think, though, a lonely view, because we're all in this world together, so we still have like within world solidarity, and I think that's where our cares and our morals come from in-world thinking. So even though all of this broader reality exists and it constitutes the alternative possibilities for us, it's not actual, actual being this indexical matter, and it's right for us to only care about the actual world. So a lot of what we believed and a lot of what we cared about is still true, and is still worth caring about. So it's not actually all that much, it doesn't involve a complete upheaval of one's life and one's value system, or it needn't to adopt this view. It's a matter of coming to recognize what possibility and necessity have always been. We just didn't realize that. They've always been quantum, but until we knew quantum theory, we didn't have a hope of working that out.
Wonderful. Yeah, there are so many different threads that one can pull on from that very nice summary. So let's sort of just perhaps situate this in the context of other theories. So can you sort of very briefly tell us David Lewis's version of modal realism, which does not talk about quantum mechanics at all, which is partially an inspiration for your theory?
Absolutely. So my theory I call like a version of modal realism. So there is modal realism of the broader kind, which in this context means taking other possible worlds to be the same sort of thing as the actual world. So the indexical actuality, the fact that all the worlds are on a par, they're all just as concrete and real as this one, they're just not actual for us. That is completely in common with Lewis's theory. But the difference is in the view about what the kind of things the worlds are. So Lewis thought that these worlds were very diverse and various, including many that had different laws of physics at the fundamental level, which I deny. So there are very many fewer of my worlds, intuitively, than of Lewis's. Lewis has many, many, many worlds for which there's no Everett world, whereas there's pretty much a Lewis world for every Everett world, or something equivalent. So I recognize very many fewer possibilities than Lewis. For Lewis, the worlds are also fundamental, whereas I endorse the approach to Everett, according to which the worlds are an emergent feature of reality. So at the fundamental level, this is an important feature of the view I haven't mentioned, there's no contingency. Because contingency is a matter of where you are in the multiverse, and the multiverse itself is non-fundamental, contingency itself is non-fundamental. So at the level of like the kind of deepest reality, that which gives rise to the Everettian multiverse, there things just are the way they are and could not have been any other way. Contingency is a feature which arrives at the higher level, the same way other distinctive features of reality like consciousness arise at higher levels only and aren't, we think, at the fundamental level. I don't think modality, or contingency at least, is there at the fundamental level. It's something that emerges, given the structure of our quantum world, at the level of a multiverse. So that much is kind of in the David Wallace, Simon Saunders, Hilary Greaves, David Deutsch kind of emergent multiverse tradition. So what I'm doing is combining ideas from the emergent multiverse approach to Everettian quantum mechanics with modal realism, but it's kind of it's a fusion which neither of the proponents of those views would have been happy with. Lewis would strongly have resisted the idea that the worlds of his worlds could correspond one-to-one with Everett worlds. He would have thought all the Everett worlds, the whole Everett multiverse, has to go inside a single one of his worlds. And likewise, a lot of the Everettians don't like tying their proposal for philosophy of physics to an account in broader metaphysics. They would much rather not make it a kind of hostage to fortune. They would like to be able to separate out modality, set that aside, get on with understanding physics, not be distracted by the kind of questions I want to ask. But this is where my holism that we talked about earlier comes in. I don't think you can keep those questions cleanly separated. So ironically, despite having a strong distaste for a priori metaphysics, I think a lot of the Everettians that don't kind of take a stand on the connection between modality and Everettian quantum mechanics end up presupposing a kind of a priori metaphysics of modality, which is a bad fit for their view. So I think they're kind of adding an unnecessary burden around their view by trying to make sense of it in the context of traditional modal metaphysics, when what it needs is to kind of be allowed its own modal metaphysics, and then the Everettian quantum mechanics just kind of can avoid many of the traditional objections to it and just altogether is a more natural total theory. Obviously, people like David Wallace aren't going to agree with that. Hilary Greaves would strongly resist the idea of mixing modal metaphysics considerations with philosophy of physics considerations. But I think that kind of attempt to keep the two things apart only results in unexamined a priori metaphysics leaking in through the back door. And so I think it's best to bring the metaphysics out in the open and explicitly aim for these kinds of total packages of metaphysics plus physics. And that's what quantum modal realism is. It's a package deal that has some metaphysical elements and some physical elements. And the aim is to find the most natural overall package deal for modality that includes Everettian quantum mechanics. And it turns out, in my view, that that's a modal realist approach.
Right. So the kind of line of reasoning that you just highlighted is one of the most convincing defenses of philosophy, broadly speaking, right? Because people point out that you can try to say that I'm not interested in philosophical questions and I'm going to do my theorizing independent of philosophical assumptions. But all you're doing when you say that is just rejecting, sort of implicitly smuggling in some philosophical assumptions and not examining them. And so it's very hard to do any kind of inquiry without some kind of philosophical assumptions in the background. And in this case, you're saying that it's very hard to do this kind of inquiry into the nature of quantum mechanics without some kind of metaphysical assumptions.
Without building them into the total package of views you end up presenting, or relying on them implicitly at some stage in the process. Yeah. So people, I think, take that point much too far. People, especially metaphysicians, like to make that point a lot, and they like to use that to try and argue for the primacy of their view. So that, you know, you're going to end up making some metaphysical commitments when you do interpreted physics, no matter what. So the best route is therefore to first of all work out exactly what metaphysical commitments to make. And then once you've finished metaphysics, start physics. And that makes metaphysics epistemologically completely prior to physics. And so, but I think that would be a mistake as well, because the idea that you can do physics without implicit metaphysical commitment is an equally bad thought is that you can do metaphysics without any like physics to help triangulate you. So the correct approach is to allow both physics and metaphysics to be moving parts in your theorizing, though maybe allow the metaphysics to wiggle a bit more because its current arrangement of parts has developed less technology. So the metaphysics kind of parts should be moved around in whatever configuration to fit in with the physics to produce the best total view, and not kind of do what a lot of philosophers of physics, I think, do, which is to kind of hold fixed some metaphysical or other philosophical commitments of the kind that they're kind of comfortable with, because that's what was kind of the consensus in their area when they were doing their PhD. For example, a non-Lewisian possible worlds account of modality, where possible worlds are some kind of abstract entity, but let's not talk in too much detail about what, in case we realize that we're actually in trouble here. So that sort of view is in the background. And so you end up with physics on the one hand, your kind of unchallenged metaphysics on the other, and then it's hard to make those two link up because they just aren't a very good fit. Whereas if you start out with the idea that the metaphysics should be whatever it takes to fit well with the physics, then yeah, you will end up with a better total view. And in most areas of philosophy of physics, it maybe doesn't matter too much, because I don't think in most areas of philosophy of physics does modality itself become the subject matter the way it does in philosophy of quantum mechanics. I say on my view, quantum mechanics is like the physics of modality, the physics of objective probability. And so it's not surprising that when we're trying to understand that, we need to engage with the metaphysics of modality in a way we don't need to engage with the metaphysics of modality when we might be talking about, I don't know, renormalization.
Right. Okay, so to get back to your theory itself, so you mentioned that according to your theory, the fundamental physical theory, whatever it is, which we don't know, could be strings, could be some funny theory that we have no idea about, that theory should be taken as necessary. But
yeah,
how do you then account for the very fact that right now physicists are considering many different possible theories as candidates, right? And clearly they think they're possible, at least, if not actual.
So there's a core distinction between metaphysical or physical or genuine possibility. All of those things mean much the same in my picture. What really can happen is the way I like to gloss it, versus an epistemic form of possibility, way things can be imagined to be, way things can be theorized to be, way things can be theoretically represented as being. And there's a link between the two, but it's not any kind of obvious one. It's like, broadly speaking, the epistemic possibilities are the ways that it is kind of physically possible for some agent to kind of represent the world using. So right, that was garbled, but if it's physically possible for an agent to wonder whether P, then there's an epistemic possibility such that P, but it doesn't mean that it really can be that P, and that should be obvious as soon as we consider mathematical ignorance. As soon as we observe that there are epistemic possibilities open to people that don't know much maths, where lots of things which are in fact theorems are false. Like for all they know, those theorems are express falsehoods. So there are epistemic possibilities for them where those theorems are in fact false. And those things aren't real possibilities, these mathematical impossibilities. And I just think the same goes for physics. So there are plenty of theories that physicists can put forward and consider seriously and do consider, which do not describe any possible way that things could be. And even our best theories, in a sense, they're impossible because they're not perfectly accurate in every respect, our best fundamental theories. And the true fundamental theory, which is presumably different from anything we've got at the moment, that's necessary, on my view. So like every theory that had ever been explicitly formulated by a physicist is necessarily false. But that doesn't stop anybody doing physics, because these are all successive attempts at working towards the true physics, which is necessarily true at the fundamental level. And we can do physics, thus conceived, while living in a world described by the true fundamental theory. So, the true fundamental theory on my view, is going to be a quantum theory. That's a prediction of the view. If quantum mechanics is false, then the whole of my view should be set aside as a relic of history. But I'm betting that quantum theory is correct. I'm pretty confident. So, sorry, I got distracted by my love for quantum theory.
Don't we all?
But yeah, the point is we can make sense of how creatures living in a world described by the true theory, a multiverse generated by the true theory, can do physics and would be very like us, constantly considering necessarily false theories, but as they improve their theories, getting them closer to the true one. And the situation is really no different from mathematics, on my view, with respect to our ability to consider, evaluate, and reject necessarily false theories.
But in the case of mathematics, the necessarily false theories are rejected on the grounds of logical contradiction, whereas here it's something different, presumably, right?
That's true. And if you were to regard modality as kind of a logical matter, that would be a problem. But as I say, I regard real modality as a physical phenomenon. Just like we learn kind of what the world is made of by doing physics, we learn what the real possibilities are by doing physics. And it turns out there aren't real possibilities where quantum mechanics is false, but there are real possibilities where, some nearby star goes supernova tomorrow. We kind of know enough about the contingency involved in galaxy formations to know that there's a real possibility there where kind of everything goes just like it has from our point of view up to the present moment, but a supernova appears tonight in the sky, and worlds where it doesn't. That much is kind of, I think, kind of robust knowledge that we've obtained of alternative possibilities.
So earlier you had this observation that the reason why we care about alternative possibilities is at least supported or helped on by this kind of Everettian view of possibilities in which they're all these different worlds and we're just in one of them. But is the reason why we care about epistemic possibilities that are not genuine possibilities, that would still need some kind of explanation, right? That your theory might not be able to provide.
Yeah, so I don't think we do care directly about them. I mean, it's why we feel a sense of relief when we discover that something we took to be an epistemic possibility is not in fact a real possibility. So I think we can kind of we care about epistemic possibilities insofar as there are representations of and kind of best guides towards truths about real possibilities. We don't care about them in their own right.
Right.
I mean, to kind of give an example, like I'm confident that there aren't any vampires because I think I know enough about science and like the ecology of planet Earth to know that it's like very unlikely to have vampires in, and enough about biochemistry to know that like vampire biology is implausible. It doesn't mean that I have credence zero in being attacked by a vampire tonight. So I like my best guess at what the real possibilities are has no real possibility there. But I haven't excluded the possibility altogether. But I can gain great solace from my confident belief that the chance is zero of that happening, even if the epistemic possibility doesn't go away completely. So I think knowledge of the chances has a kind of weight that no kind of it gives us a kind of assurance about the future that we can't get without knowledge of the chances. That's the functional role that it's playing.
Yeah, I mean, when I was a kid, and if I felt afraid of the dark, of ghosts or whatever, and then if I just reflected on, what would be the kind of physical processes that would be required to make a ghost, and start understanding that that's actually quite implausible, that there would be something that can have all these powers but still not really interact with you, so that would kind of give me a sense of reassurance. And that's what you're pointing at, is that it was an epistemic possibility, and then reflection on the physics leads me to think that it's not a genuine possibility, and that lets me sort of relax, right?
Yeah, and similarly, you suppose you gamble with somebody and you lose, and then you learn that the dice were rigged. You lost it. You lost. But the fact that the probabilities weren't what they thought that you were kind of gives a sense of outrage. Like we care about the probabilities of the world, and there are guides to all our actions through expected utility theory, or whatever version of every plausible like formal theory of rational choice is going to give a role to estimation of objective probability. I think. I mean, obviously that's not uncontroversial, because very little is uncontroversial. But I think it's kind of very clear how chance is at the center of a lot of the most important decisions we make, in everything from weather forecasting to economics to gambling, to like split-second chance judgments made while driving. If there weren't objective probabilities, life would be extremely difficult. And so the view that I'm describing uses objective probabilities as kind of the bridge between everyday life, rational choice, kind of science-informed decision making, and the underlying physics. So you have probabilities from the physics that ramify up through the levels to be still objective by the time they get to the level of everyday life. And so ultimately, it's the objective probabilities in fundamental physics coming out of this measure over the space of possible worlds that is the source of all of our like well-founded decision making.
Right. Okay. Wonderful. So this is a nice bridge to one of the main topics I want to talk to you about, which is chance and probability in the context of Everettian and quantum mechanics, especially as viewed through your lens. So there are several ways we can go about this, but can you sort of just tell us how you think about chance in this in your framework? Is it so you mentioned the phrase a measure over possible worlds, but this still seems somewhat disconnected from what we think of as chances. Yeah, I toss a coin, it lands heads with such and such frequency, or I can make certain kinds of bets based on my knowledge of the chance of this coin. So how do you connect the measure over possible worlds to this more ordinary understanding of chance?
Yeah, good. So chances are a multifaceted thing, and the chances you just mentioned are kind of high level chances. So these are chances at the level of the decidedly non-fundamental phenomena of humans making decisions, gambling, and so forth. But I think ultimately the fact that there are like well-defined kind of accessible and useful probabilities at the level of human behavior is ultimately grounded in the probabilities at the microscopic level of the behavior of the physical ingredients. And so ultimately, that is to say, the view I have is a form of reductionism, whereby specifying the probability distribution over the micro physical histories of the world, specifying how likely each fully maximally detailed description of physical reality is relative to every other maximally detailed description of physical reality. A probability distribution over those is going to fix a probability distribution over all the higher level phenomena, which can be multiply realized by the different microhistories of the various kinds. So there's kind of a two-step thing. There is, first of all, we ensure that we have a probability distribution defined over the like maximally detailed, or as detailed as you can get without running into decoherence, at least, worlds. And then you rely on some broad form of physicalism to argue that all probability, since there is like a total probability distribution, like a single total probability distribution covering all of the microphysical states, that's going to determine probabilities for all of the combinations of those states which you might put together into a higher level fact. So, you know, even though there's many microhistories in which I win this bet, you can just like sum the probabilities of all those microhistories in which I win the bet to get the probability of the macro fact I win the bet. And so it's those chances attaching to the individual worlds ultimately that are in the aggregate giving rise to the chances for the higher level properties. So there's a certain kind of physicalist, I mean, some would say that's like a very reductionist worldview. I don't think it's particularly reductionist, but I do think that you need to have that if you have a complete distribution of probability at the micro level, that's got to fix everything else. So I'm not a strong emergentist in that sense. Anyway, so then the question is kind of where does that probability distribution over microhistories come from in the first place? Answer, it's a feature of the physical world that is described by the squared amplitude of the quantum state. And that's kind of what quantum mechanics tells us it is. And we need not necessarily be able to characterize that in any independent terms for that to be an adequate understanding. That's the kind of defensive thing to say. But there is, of course, a big debate about whether probability makes sense in Everett. And many people have criticized Everett, often harshly, on the grounds that it can't really make room for probabilities. And these people will be raising an eyebrow, because here I am saying that the provision for probabilities is one of the biggest features in favor of a worldview that incorporates Everettian quantum mechanics. So there's a few things going on here. One of the things is that I think the metaphysics, the link between the physics and the metaphysics I make, as well as like having rewards in terms of a good theory of modality, it also has rewards in terms of helping us solve and respond to problems with Everettian quantum mechanics itself. So in particular, I think the probability problem is much more tractable, much more readily solvable if you have my link with modality in the background than if you don't. Because a big objection to probability in Everett is that people say some things like, probabilities should attach to alternative possibilities. That's kind of what it is to be a probability, is to be a measure over an alternative set of alternative possibilities. And look, in Everett, these worlds are all equally real. They're not alternative possibilities. They're like all there together. And so there can't be meaningful probabilities defined over them. And my view, of course, says that these worlds aren't all co-actual. They are all alternative possibilities. They are what it is to be an alternative possibility. That's just what alternative possibilities are, these different Everett worlds. And so probabilities are the kind of thing we thought they were after all, even though they're Everettian. So in fact, we haven't abandoned this kind of core conceptual feature of probabilities. They're linked to alternative possibilities after all. We've retained it. And that's why I think that my approach does better when it comes to the probability problem than many other views. That's not to say I think that probability is wholly unproblematic. For the following reason, there's always been a challenge. I mean, I would trace this back to like the general problem of induction. But since people have been talking about objective probability, there's always been this kind of normative challenge. Why should we care what the objective probabilities are? Why should they rationally guide us? Why should knowing that this coin is fair lead me to want to, not bet at uneven odds on it? Only if the chances are like relevant to my decisions does that seem rational. So how could they be relevant to my decisions in that way? And some people have said, David Deutsch has said, David Wallace has said, that Everett is actually better off with respect to this problem than other theories. Because you can prove, says David Wallace and David Deutsch, that and others, Simon Saunders has endorsed a version of this argument, that a rational agent in the Everettian universe will regard the quantum weights as objective probabilities. That is, there's a kind of argument that given the Everettian ontology, these quantities, the branch weights, the Born rule weights, the squared amplitude, whatever you want to call them, it is rational to behave as if they are probabilities. It's rational to treat them as probabilities in your reasoning, if you're an Everettian who knows you're living in an Everettian world. And I don't think those arguments succeed, broadly because they try to do too much. So they effectively try to solve the problem of induction. And I don't think that can be done. There's a lot more to say about that, and we can talk about it if you're interested. But I think that rather than showing that the branch weights are probabilities, what we can take these arguments as showing as like they are the best candidate to be probabilities. So their probabilities, if anything, is. mean, we haven't established that they are probabilities as opposed to there being just like no such thing as objective probability and rational action being impossible. But like to the extent that rational action is possible, and to the extent that there's anything that plays an objective probability role, it's these. They're like the uniquely best candidates to be probabilities. Still doesn't make them probabilities, but it's part of the best total theory that they are probabilities. So there's a certain amount of kind of there's a certain, in a certain sense, it's less ambitious than what Wallace and Deutsch have tried to do. So I see their kind of arguments as more like a kind of consistency check, as an argument that if we take the probability, these vulnerable weights as probabilities, everything will work out just the way we expect it to with respect to things like decisions. I don't see them as establishing that you're irrational if you live in an ever universe and you don't do that. But then I think nothing could do that, because nothing can solve the problem of induction, which is to show that it's rational to treat some features of the world as rationally constraining beliefs about the future.
Right.
You're not being irrational if you choose to continue to expect one particular outcome, no matter what the chances are. You're theorizing badly. You're making a mistake, but that mistake isn't like a pure failure of rationality.
Right. So just to sort of get a sense of what the picture is supposed to be, according to your theory, so suppose I toss a coin and I say that with 50% probability is going to land heads and 50% probability is going to land tails. What that means is something like the quantum mechanical measure over those worlds in which the coin lands heads is 1/2, and the quantum mechanical measure over those worlds in which the coin lands tails is 1/2. And however, you don't think that it is correct to say, or do you think it's correct to say that half the worlds, the number of worlds in which the coin lands heads is equal to the number of worlds in which the coin lands tails, right? Like,
no, I don't think it's correct to say that, though I think it might yet turn out that it's correct to say that kind of on a technicality. So I think we genuinely don't know enough about cosmology and fundamental physics, like Planck scale physics, to know whether to know some key features of the space of Everett worlds. In particular, I think it might yet turn out that there are infinitely many worlds in every set. That is to say, kind of the space of world is infinitely fine-grained. That something would have to change with our current understanding of decoherence, but I'm not sure that there aren't cosmological developments that could change things in that way. I'm not a physicist, but I'm trying. I try to be cautiously open-minded about these sorts of things. And so if the space of worlds is one way it might epistemically possibly turn out to be, then there would be the same number of worlds in each set, but that trivially so because there'd be an infinite number in each set. What we can't do is use like finite relative numbers to like there being like twice as many worlds in this set as that set to determine the probabilities. Insofar as you grain the worlds in such a way that you can ascribe finite numbers to them, what you're doing is approximate, because you can fine-grain your history space. This is a kind of well-known point in the literature on Everettianism. You fine-grain your history space in a slightly different way. You still get decoherence and effective isolation of the worlds, but you get a different number of worlds in your history space. And the kind of commonly accepted view amongst Everettians in response to this is that the number of worlds just doesn't have physical significance. There's like some indeterminacy in how many worlds. It's just kind of, people talk about this in different ways, and it's an interesting point, but it's not even kind of a well-defined feature of what's really there to be able to determine the probabilities, let alone whether it would get the probabilities right. It wouldn't, because it would diverge from the Born rule. So yes, it might be that we can make sense of some well-defined notion of numbers of worlds. It might even be that that well-defined notion is finite, that we really can count worlds. I wouldn't want to rule that out, though I think David Wallace, for example, would be very skeptical of that. In that situation, we would just simply have a tension between like the relative proportion in terms of number of worlds and the relative weights of the worlds. And in that situation, what my view and what I think Everettians have to say is that the quantum weights are what determine probabilities. So the way I can reconcile that is by thinking that the principle I could equally likely be in any of these worlds is just a bad principle when it's applied across different worlds. And people are misled because they think it's a good principle within this world. So if I learn that like this world is made up of 10 like duplicate universes lined up in a row, I might think a priori I'm equally likely to be in any of those. But all of those are in like the same Everett world. And so the fact that I might think I'm equally likely to be in universe A or B or C or D or E of these like lined up universes doesn't tell me how I should distribute my credence about whether I'm in this Everett world or that Everett world, because I kind of have to cross Everett world boundaries to get to the next Everett world. And I don't think kind of the indifference principles for self-location work cross-world the same way they work in-world. So I would think I can kind of still get a plausible self-locating epistemology, even without being driven to branch counting. I think a lot of people reason from a like indifference principle about where I'm located in this world to an indifference principle between worlds and then derive branch counting from that. And I think the mistake there is moving from indifference in my locations within this world to indifference to my possible locations across worlds. Right. That's a long story, and the book goes through the long story.
Yeah, this is obviously one of the biggest sticking points that people have when they consider Everettian quantum mechanics, because they'll say, okay, look, you have something like a Schrodinger's cat experiment, and suppose with probability 1/3, the cat is given the sleeping drug, and then with probability 2/3, it is not. And well, the superposition structure seems to suggest that there's, well, one world in which the cat is asleep and one world in which the cat is not asleep. But what we want to say is that with probability 1/3, which is not the same, it's not symmetrical with the case in which it's awake. And I guess the point you're trying to make is twofold. On the one hand, you're saying one way to think about it is that the sort of, if what it is, so quote unquote, the number of worlds, if that's infinite, has a measure that's twice as large as the measure of the worlds in which the cat is asleep. Just as if I take a line that's twice as long as another line, even though the number of points in them is the same, it is still true that one line is longer than the other.
Yeah.
But you're not necessarily committed to that way of thinking about it, right? Because you don't know whether each world is sort of infinitesimally thin in the space of all possible worlds.
Yeah. So I don't know in that sense whether it's analogous to the line. These issues around probability are timeless with Everett. There was a recent debate, which I expect some people listening to this may have seen, between Sean Carroll and David Albert on a Harvard Zoom workshop about probability in Everett. And the objections being made by David Albert, he's formulating them extremely sharply, but that some of the kind of conceptual core of the objections is the same sort of objection that Everettians have always struggled with, and I think they are good objections, relating to how you think about probabilities concerning the future, in particular. And as I mentioned, my version of Everett has a parallel world view, not a splitting worlds view, and that feature very significantly helps with many of those problems relating to, I mean, I think it solves the problem of how to make sense of uncertainty about the future in Everett. Likewise, I think the different links to the metaphysics of modality I use help to solve many of the concerns people have about the conceptual role of probability being too mangled in Everett, because it's been separated out from alternative possibilities. I put them back together again. So I have this picture which uses a little bit of metaphysics here and there to like kind of slots in a couple of suitable pieces of metaphysics into the overall picture here and there, in order to solve these problems with the physics. But nobody seems to like that. Nobody in the debate over Everettian probability is motivated by that, unfortunately, or so it often seems, because the Everettians think they can kind of win this dispute without the help of any metaphysics, and the metaphysics is just going to complicate this, and they think they already have all the resources they need to answer the challenge. Whereas the objectors think that this isn't what the Everettians are mostly endorsing, so I kind of don't need to worry about the fact that it avoids the objection. Neither side, unfortunately, is interested in my my resolution of the Everettian probability puzzle. That's
well, I'm sympathetic. I'm not fully convinced, but I'm definitely sympathetic. Okay, so one thing that you mentioned throughout the discussion, which we should probably spend a little bit more time on, is this way in which you separate your view from the sort of dominant view within Everettian quantum mechanics, which is the idea that all the different branches are always distinct, even though we might think that there's a kind of branching going on. That is, there's one branch that splits apart into two branches. And presumably, in the kind of Schrodinger's cat situation, what you're going to say is that there were always two cats in a way, or at least two cats, or two kinds of cats, or two sort of families of cat worlds. And these two families of cat worlds will, after a certain time, start showing differences. But before the radioactive atom decayed, all these families of cat worlds had the same character. Whereas an ordinary Everettian would say something like, there was exactly one kind of cat world that split up into different kinds of cat worlds. Does that roughly make sense of your distinction there?
Yeah, that sounds right.
Okay. And yeah, and this is supposed, so according to this has the sort of somewhat counterintuitive consequence that if I say, I am here now, there are actually, I don't know, infinitely many, a very large number of sort of copies of me or counterparts of me that are in every respect having exactly the same experience, living in the same sort of environment, who will in the future go on to have different experiences, but they're all sort of here now, right? Is that
Well,
okay?
no, because it's not just you that there's multiple of. It's space-time that there's a lot of.
Okay.
Each of these versions of you, I wouldn't. I mean, I don't actually like this kind of terminology of, but it's something that people often say, kind of multiple versions of you. The way the metaphysics works on my picture, there's only one of you. There's only one of me. There are many other people. They may have names that are the same name as yours. They may look the same as you, but they are their own person living their own life, and you are fundamentally concerned about yourself and not about them. And the reason why you want to find out which world you're in is because you want to make your life go as well as possible. So you want to know about the features of your world to do that. I mean, free will is a whole extra separate problem, and the short answer there, I don't think it's any worse off in this picture than it already is. But set that aside. So there are many other people in other worlds, just like you, but each of them have their own universe with their own space-time and their own galaxies, their own friends and family. And so, no, you're the only one there. I'm the only one here. But we resemble other bits of reality much more than we might intuitively have expected to.
Right.
Qualitatively speaking, we are not unique. Because, of course, there are going to be many worlds which diverge only long after both of us are long since gone. And so any two worlds that diverge only after that, those two worlds contain perfect duplicates of both my life and your life in. And so there are innumerable people that aren't just duplicates of me and you up till now, but will be duplicates of you and me right to the very end of their lives. So, go look through the multiverse. You'll find a lot of not just people that look like you now, but a lot of lives that look just like yours. And in that sense, we're not unique. But I've got used to that. I'm unique enough around here, as are we all. So I basically think that most of what we thought was kind of reasonable to have an attitude to the whole of reality remains reasonable, but not as an attitude to the whole of reality, as an attitude to actuality, which is pretty similar to what we thought the whole of reality was like. So our practical attitudes, our values don't need to change at all, unless those values were for some reason tied to the deepest metaphysical facts about the nature of modality. So if, for example, someone was a member of a religion that worshipped like a modal realist religion of the Lewisian kind that worshipped a god in another possible world, they might be pretty upset to find out that on my version of modal realism, that the world with that god in doesn't exist. There's no quantum world like that. And so their god doesn't exist. Like that would be a case in which converting to Everettianism, understood my way, would alter your value system. You'd have to have some pretty peculiar values to start with. For people that value the kind of ordinary things that are like, the people and the landscapes around them, none of that needs to change just because you adopt a much broader view of reality beyond our everett world.
Right.
I did get off the original question there. It is a peculiar feature of this view that it has so much proliferation of duplicates of things, not just of individual people, but of whole planets, whole solar systems, whole galaxies, all get duplicated a lot. But I mean, the world's a complicated place. It's pretty big, and it's more of the same sort of thing. Like once you've kind of got used to the, like, including in your conception of physical reality, 100 trillion galaxies, you know, a few more, a lot more, it's just more of the same. So I don't really see any pressure to think the universe is small. I just see pressure to think that it matches what we know about it.
Right. Yeah, wonderful. Okay, so I guess we're coming up close to the end of our time. So perhaps maybe I can get in a couple more questions about this question of what we care about if this theory is right, because that's something that people might be concerned about, even though you're trying to reassure us that, you know, this theory leaves everything as it is and you can go about your life without worrying about what your counterparts are doing, or at least, yeah. So, well, so one thing that I kind of liked about Everettian quantum mechanics, which your line of reasoning is sort of pushing back against a little bit, and even other Everettians say the same thing, so you're not sort of distinct in that way. But so, right, so suppose someone is taking a risky action, right? And they take the risky action, but it turns out fine, right? Like they're driving recklessly, but they don't crash the car. Now, ordinarily, we still want to be able to criticize that person, and the person saying, well, it all worked out, so what's the big deal? You know, on a kind of Everettian view, you might say, well, look, there are other worlds in which you took that action and it ended really badly. And the sort of the weight of that world is actually pretty high. So you shouldn't have done that. But according to the kind of line that you were saying, that response won't be available to me, right? Because you would just say, well, those are alternate possibilities. And Professor Wilson tells me that I should only care about the actual possibility. Do you think, how do you respond to that?
Yeah. Sorry, I lost the thread for a moment there. So I appreciate the feature of the interpretations of Everett that you're talking about, that say kind of risk is, they kind of give a sense in which risk is intrinsically bad. Because if you take a risk and it comes off in your world, still you kind of cause lots of other people in other worlds to suffer, and that's kind of intrinsically bad. And I guess I think that is I see the appeal of that, but I don't think it's really a revision of our like evaluative thinking that we want or need to make. Because I think we can make sense, we already could make sense of the badness of having taken a risk in lots of ways that don't require it to be kind of intrinsically bad. So I guess I think there's something tempting there, but I can't appeal to that that way of thinking. Ultimately, I think appealing to that way of thinking is going to cause more trouble than it gains. This is the kind of thing that David Papineau has pushed, and I think very eloquently in some of his work. And there's a kind of two-pronged thing. There's the kind of arguments that Everettians are kind of just as well off as anybody else when it comes to making sense of objective probability and why we should make decisions in accordance with the objective probabilities, and arguments that they're better off. And the thing you bring up is a kind of is of that latter kind. It's an argument that Everettians actually can make better sense of our practice with chance. I mean, luck is a very puzzling thing already. We already have like legal systems whereby it isn't, even though you might think it should be, considered equally morally bad to take a risk and kill somebody versus take a risk and not kill somebody. we do regard the person that takes the risk but gets lucky as having done something less bad in some, like, all things considered sense than someone that takes the risk that comes off badly from. This is a so-called problem of moral luck. Some people will respond by saying we should just kind of reorganize our entire system of evaluating so that it's about the kind of action given what you reasonably believed. That is, it's not the consequences. Like, having a worse consequence doesn't make the action worse, doesn't make you more blameworthy, doesn't mean you should be punished more. So we should punish everybody that drives dangerously just as much as we punish people that cause death by dangerous driving, or at the moment those two things are very differently punished. And my sense is that morality is extremely complicated, and the correct attitude to take towards people that kind of knowingly endanger other people or take unnecessary risks with other people is complicated too. And yeah, this is not a very satisfying answer, but what I'm gesturing towards is an account of the badness of having taken a risk and it comes off badly, that isn't because you've kind of harmed people in other worlds, but because of what it shows about the actual world, what would happen if you were to do that again. And what it kind of says about your dispositions and your character in the actual world. And also, you know, humans being humans, we and people affected might be psychologically affected by those things and trust be breached. Like there's a lot of complexity there that I think provides resources to do without that thought.
Right.
It is. So that was a long-winded answer, and as usual with long-winded answers, it's because I'm not entirely happy with what I have to say on the subject. So I guess that is it is maybe something I would count as a cost of my view compared to other Everettianisms, that it gives up that nice cool thing, but I think it ultimately it's worth sacrifice.
Right. Yeah. So according to your view, there are all these different alternate possible worlds, but we should only care about the actual world, even though the other worlds are real. Right?
We want to learn about the other worlds, but we want to learn about them because that enables us to, in our actions, maximize things being the way we want within the actual world, because the actual world is the locus of our values.
Right.
And it's like a kind of hardcore version of the way we care about our friends and family more than our people we don't know. We care about people we don't know on Earth more than we care about like duplicates of those people in distant galaxies. And I want to say we care more again about those people in distant galaxies than we care about those in another world, except this time in a matter of degree, not merely of kind. There's a lot to argue about here. We have these sorts of moral objections against any sort of view that makes reality as a whole non-contingent. People think, what's the point of doing anything if the totality of reality will be the same whatever I do? And the answer is, you know, the proper locus of concern for you, where what it is kind of appropriate for world-bound creatures to care about is world-bound events. That's just our lot in life. Right. We're in a world, we're stuck in it, we're all in it together. So like the best sort of ethic we can achieve is a kind of worldwide solidarity. Everett worldwide, that is.
Okay, wonderful. So closing question, what are some questions and research directions that you are particularly excited about?
Well, I mean,
related to our conversation.
Yeah, I'll say briefly what I'm doing at the moment, which is kind of a next big project after this book. So this is having been in production from when I was an undergrad and first came up with the idea. Like 19 years later, it finally exists, and so I can do another project. I hope this next one won't take 19 years. I have I have a team funded by the EU. At the moment at the University of Birmingham called FriendPhys, and we're working on the varieties of explanation in physics, and in particular on non-causal and metaphysical explanations in physics. So the aim is to really, one way of putting it is to explain where explanatory directionality comes from in physics. That would be a nice thing to know. The directedness of an explanation in fundamental physics. So I'm thinking about those sorts of things and enjoying working with my team. We're all working on aspects of that sort of thing, including philosophy of statistical mechanics and philosophy of quantum theory and EPR and those sorts of things. But in terms of things that are happening in philosophy of physics right now, in physics right now, you can hardly go through, I think, like a serious discussion of the metaphysics of physics without mentioning quantum gravity sooner or later. Nearly every philosophy of physics talk you go to these days, it would make sense to put your hand up and say effectively, but what about, how does quantum gravity bear on this? Because it bears on nearly everything. And given that we have, if gravitational wave astronomy takes off and becomes a big thing, that might give new cosmological lines of inquiry that might bear on a lot of these questions. So I would really love to know about large-scale facts about the universe, finite or infinite information content, those sorts of questions. And that is just something that physicists are lucky enough to be working on that stuff, and philosophers are lucky enough to be able to follow the physics at the cutting edge. Will be able to have a field day with, just because it bears on so much else in philosophy of physics, one way or another. And in some ways, it feels like some traditional areas of philosophy of physics, like philosophy of space-time, they're kind of on pause until we get some real progress in quantum gravity to report. So that's a big area of research. I'm really interested by the, I know not enough about this to work on it myself, but I'm really interested in an area that a person from my project, Katie Robertson, is working on at the moment, the intersection of like quantum mechanics, statistical physics, and information theory. And I think and this connects up with the question about applicability of mathematics we were talking about earlier. So broadly speaking, I'll come back to that question of the applicability of mathematics. That is the question that I love to think about the most. And so I like research agendas and directions that bear on that question. And I think this modal metaphysics approach does, but I also think these questions of cosmology and of connections to computation and statistical physics and applied mathematics are also really relevant to that question of the applicability of mathematics, which is, it's the greatest of all metaphysical problems. Why not? And we still haven't solved it, and it's fun to think about.
Al Wilson, thank you very much.
Thank you. That's been fun.